Welcome to my presentation. I am K. Rajalakshmi, lecturer, PG and Research Department of Chemistry, Rajalakshmi Ramaswamy College, Tiruchirappalli. In this video, we are going to discuss column chromatography. In this presentation, we discuss about what is chromatography, origin of chromatography, types of chromatography, and what is column chromatography. First, definitions of chromatography. Chromatography is a Greek word, means color writing. Chromo means color, graphene means write. Chromatography is a technique for separations of mixtures into their components in order to analyze, identify and purify the mixture. The history of chromatography. The Russian biologist Ms.K invented chromatography in 1900 during his research on plant pigments. He used liquid adsorption column chromatography. Chromatography is an analytical separation technique by which mixture of two or more compounds can be separated into individual one using stationary phase and mobile phase. There are three main components in chromatographic technique. First, analyte. The sample to be separated is called analyte. Second, stationary phase. It is a stable and fixed part which interact with the molecules to be separated. Third, mobile phase. It is a movable part which helps the analyte to interact with stationary phase. Classifications of chromatography according to mobile phase. In liquid chromatography, the mobile phase is a liquid. In gas chromatography, the mobile phase is a gas. Classifications of chromatography according to the packing of the stationary phase. Thin layer chromatography. The stationary phase is a thin layer supported on glass, plastic or aluminium plates. Paper chromatography. The stationary phase is a thin film of liquid supported on an inert support. Column chromatography. Stationary phase is packed in a glass column. Chromatography is broadly classified into two types based on the interactions of analytes with the stationary phase. Partition chromatography. Principle. Separation is based on differences in solubility of components between two immersible phases, typically a liquid stationary phase and a liquid mobile phase. Key techniques. Thin layer chromatography. When the stationary phase is a thin layer coated on a plate and acts like a liquid in partition system. Paper chromatography uses paper as a stationary phase which holds papers, making it a form of liquid-liquid partition chromatography. Adsorption chromatography. Principle. Separation is based on the differences in the adsorption of analytes onto a solid stationary phase from the mobile phase. Key technique. Column chromatography uses a solid stationary phase packed into a column. Types of chromatography. Paper chromatography, thin layer chromatography, gel chromatography, column chromatography, ion exchange chromatography, gas liquid chromatography, affinity chromatography. In this video, we discuss about column chromatography. Column chromatography may be defined as a separation process involving uniform penetration of a liquid solute through a column packed with finely divided material. In column chromatography, an absorbent like alumina or silica gel is packed in a glass column. The mixture to be separated or purified is poured on the top of the column. The components are then eluted out stepwise by a suitable eluent. Principle involved in column chromatography. Adsorption. Components interact with the stationary phase. Polarity. More polar compounds move slower while the less polar ones move faster through the column. Elution strength. The stronger the solvent, the quicker it elutes compounds. Experimental procedure in column chromatography. Packing the column. The column is commonly made up of glass. A cotton is pressed down on to the stopper, thus closing the column tube so that the powder adsorbent is retained and the liquid passed through. Stationary phase is packed into the column, loading the sample. The sample mixture is introduced at the top of the column. Elution. The mobile phase is passed through, carrying different components at different rates. Final collection of the sample. Different fractions are collected as a component separate. This image illustrates the step-by-step process of column chromatography. First, column setup and sample loading. The column is packed with a stationary phase, usually silica or alumina. The sample mixture is loaded on top of the stationary phase. Second, addition of mobile phase. A mobile phase is added. This mobile phase starts to move down the column by gravity or pressure, carrying the components of a mixture along with it. Third, separation begins. Different compounds in the sample begin to separate as they interact differently with the stationary phase. Compounds with weaker interactions with the stationary phase move faster and begins to elute. Fourth, stronger interaction. Some compounds bind more strongly to the stationary phase and move more slowly. Separation becomes more distinct and different colored bands represent different compounds. Fifth, elution and collection. As the mobile phase continues, compounds elute at different times. Each compound is collected in separate fractions. The final column shows all compounds separated and collected individually. Applications of column chromatography. Pharmaceutical purification, separations of drugs and natural products. In biochemical research, purifications of proteins and nucleic acids. Environmental testings, analysis of pollutants and contaminants. Food industry, detection and separation of food. Thank you all for your patient listening.